Hi there, welcome back. We are going to be tackling another shape problem from paper 1, June 2023, question 26. So we're presented here with a circle, and within that circle we have a square, OPQR. Now, the question itself looks pretty challenging because we're actually told a couple of bits of information. First of all, we're told that the circumference of our circle is 20 pi. But the purpose of this question is to prove that the ratio of the perimeter of the square, which we currently don't know, to the circumference of the circle can be written as root a to pi, where a is an integer. So what do we know? Well, the only thing we really know is the circumference. So we're going to start with that, and we're going to, like any of these type of questions, start with what you know and see where it goes. So we're going to write down our circumference of a circle equation, which is 2 pi r, and we know that this is equal to 20 pi. We're told this in the question. We can combine those two facts, equate them, and this will give us a little bit more information. So we know that 2 pi r must be equal to 20 pi. We can cancel our pi's because they appear on both sides, so we know that 2r is 20. So from that, we can establish that r is equal to 10 centimetres. Okay, I'm not going to write the units. So I already now know that we have a 10 centimetre radius of our circle, so that's going to help us. Now, if you look at that radius, that actually forms the diagonal across OQ of our square. So if I were to draw, or at least try to, if I was to draw my triangle within that square, so we've got O, we've got R, and we've got Q, and we know that this is a right angle because it's a square, and we now know that this is 10. We're trying to find our side lengths, both of which are x, because we know that they're both equal. From this, you should see that we need to sort of use Pythagoras. So we know that from Pythagoras, a squared plus b squared equals c squared. In this case, a squared is x squared, b squared is also x squared, and c squared is 10 squared. So we can form an equation, and we end up with 2x squared equals 100. So x squared, therefore, must equal 50. So I know our one side length of our square x is equal to the square root of 50. Now, at this point, I'll think about simplifying this, but notice that the a is the only thing under the square root sign. So what we're now going to do is actually work out our perimeter. The perimeter of our circle we're going to call P, and I know that that's equal to 4 lots of our side lengths, 4x, which is equal to 4 root 50. Now, we need to somehow squeeze that 4 into the square root sign, or under the square root sign. So we can kind of do an opposite of simplifying surds, and we know that 4 is equivalent to root 16, and then we can apply our surd laws, and we can multiply those two integers together. I know 16 times 5 is 80, so I know that that's root 800. So what we're after here is the perimeter of our square, which is root 800, and the ratio would be to, in this case, 20 pi. Okay, we're nearly there. We need to simplify this. So what is the square root of 800? Well, actually, the square root of 800 is 10 root 8 to 20 pi, and we can simplify that ratio to root 8 to 2 pi. We're very, very close now. Root 8 we can now simplify once more using surds from root 4, root 2, which is 2 root 2, to 2 pi, and then finally divide through by 2. So our final answer will be root 2 to pi. It simplifies actually quite nicely, and there's our solution, and there's our 4 marks. Thanks once again for listening, and we'll catch up soon. Paper 1, November 2020, question 23, another shape question. So what it's asking for 4 marks is to prove that the quadrilateral ABCD is in fact not a cyclic quadrilateral. Okay, so what that basically means is we're trying to establish whether or not the angles opposite, so B to D and A to C, sum to 180, because in a cyclic quadrilateral, opposite angles will sum to 180. So we're trying to disprove that fact. So we know that the angle sum of any quadrilateral is 360 degrees. So what we can actually now do is form an equation where we add all the angles. So we have 4x, we're starting from A, and we're moving to B, plus 5x plus 30, plus 92, that's angle C, and then plus x plus 36. Okay, and we are going to equate that to 360 degrees. So we can simplify this. So we're going to collect all our x terms together. We have 4x, we have 5x, and we have x. So that's going to make a total of 10x, nice and simple for non-calculator paper. And then we're going to add together our numerical terms. So we've got 30 plus 92 is 122, sorry, and another 36 is 158. So plus 158 is equal to 360. So a bit of mental arithmetic here. We're going to subtract 158 from 360. So we're going to take 160 away, which is 200, and add 2, so it's 202 degrees. Okay, so we now know that x is equal to 20.2 degrees. A little bit awkward to work with. So what we now need to do is establish whether or not our angles opposite one another sum to 180. So the logical one to be choosing, or two angles to choose, will be our 4x plus 92. Okay, so we're going to work out what 4x is, and then we're going to add 92 to it. And you can already see that this isn't going to be 180 degrees. Okay, but for a formality point of view, we're going to go ahead and finish this. So 4x is going to be 80.4 plus 92, which is equal to 172.4 degrees. Okay, so just to finish things off, 172.4 does not equal 180. Therefore, 3 dots, standard notation, not a cyclic quadrilateral. I'm going to just write quad. Okay, so we've proved that this isn't the case, and we've secured our 4 marks. Thank you very much for watching. Catch up soon. From paper 1, non-calculator paper, November 2020, question 12. So we are basically given a design for an earring. It's made up of a big circle and a smaller quarter circle, and we are told that the ratio of the radii is 7 to 2, and we're also told the radius of the large circle is 21 millimeters. So immediately we can sketch this in. So r is equal to 21. I'm not going to put the units in for now. Okay, so first of all, to get our first mark, we are asked to find the radius of the quarter circle, or rather prove that it's 6 millimeters. So I know that 21, which is our large circle, to r is the same as the ratio of 7 to 2. So I'm just going to use a simple scaling up and multiply 7 by 3, and therefore I've got to multiply. So this is pi. I multiply 2 by 3 as well. So therefore the radius r is equal to 6 millimeters. Okay, so there's the first bit done, and there's our 1 mark. Pretty straightforward. The second part of the question is now asking to find the total length of the wire used, i.e. the perimeter of both shapes, and we need to give that answer in a specific form, which is a pi plus b, where a and b are both integers. Okay, so this is part B. So what we're going to need to do is work out the circumference. We'll call that C of our large circle. So that's the easy bit. We can just do C equals 2 times pi times r, which is going to be equal to 2 times pi times 21, which is going to give us our 41 42 pi millimeters. Okay, again, I'm not going to put the units in. So the next thing we need to do is work out the perimeter, and we're going to call that P. Okay, and that's going to be made up of our two radii, one there and one there. So we can already sketch those ones in. They're both 6. Let's make that a little clearer. That's 6 millimeters. That's 6 millimeters. And what we're going to be after is this little bit, which is the quarter of the circumference. So that's the bit x we're interested in. Okay, so I know that x is going to be equal to, again using our circumference formula, 2 pi r, 2 pi times 6, which is the radius of our small quarter circle. And because it's a quarter circle, I can divide that by 4. So I end up with 12 pi upon 4, which simplifies out to 3 pi. Okay, so now I can work out my perimeter, which is effectively going to be the same as x plus our 2 lots of 6, our 6 here and our 6 here, giving me 12, which is equal to 3 pi plus 12. So we want the total length of wire, so total length, and I'm going to call that L. And I can simply get L by summing a circumference and our perimeter. So the circumference of the big circle, the perimeter of the small quarter circle, and I end up with 42 pi plus 3 pi plus 12, and I can simplify that to 45 pi plus 12. And now I can put my units in, just to be sure, millimeters. Okay, so there's our 4 marks, so giving us a total of 5 marks, which was actually not a bad question when it's broken down. Thanks once again for listening, and catch up later.